This video is about the introduction to organic chemistry. It's the first module of Unit 2 in OCR's AS Chemistry A. And if you haven't seen organic chemistry before, the first question you're probably asking yourself is, what is organic chemistry? And it's a type of chemistry that affects all areas of our lives. It affects clothing, medicine, cosmetics, everything. And the main factor for organic compounds are that they all contain carbon and that they are carbon based. Hydrocarbons are the most simple organic compounds, and they only contain hydrogen and carbon, given away in the name. Almost all supplies of hydrocarbons are obtained from fossil fuels like coal, and the chemistry of carbon is extremely vast. There are about over 10 million different carbon compounds that are known, and it's estimated that around 300,000 are discovered each year. Another question you might ask yourself is, why carbon? Why is every single organic compound carbon based? And the reason that carbon can form so many different compounds is because a carbon atom can form bonds with another carbon atom to make chains or rings. A carbon atom can form a single, double or a triple bond with another carbon atom. And also carbon atoms can bond with other atoms of other elements, such as oxygen, hydrogen, nitrogen, phosphorus, or any of the halogens. Right, looking at bonding in organic compounds, carbon has 4 electrons in its outer shell, and this means it can form 4 covalent bonds with either other carbon atoms or other atoms of other elements. And I'll show you some examples down here. Here's the alkane methane, and as you can see there's 4 carbon bonds attached to the hydrogen, so there's 4 covalent bonds attached to hydrogens. In ethene, there's a double bond between 2 carbon atoms, and then there's 2 other bonds on each side attached to hydrogen, and because carbon only has 4 electrons in its outer shell, there's 1, there's 2, there's 3, and there's 4, so there's only 4 bonds per carbon atom. Right, here's where the key definitions start to come in, and at the end of the video I'll do a section where I'll go through every single key definition of this certain topic. Right, here we're looking at saturated and unsaturated hydrocarbons. So a hydrocarbon is a compound of carbon and hydrogen only, which we learned previously, and an example of this is methane or ethene. A saturated hydrocarbon has single bonds only, so like methane, there are no multiple carbon bonds, so no double or triple bonds. Unsaturated hydrocarbons are hydrocarbons that contain carbon to carbon multiple bonds, like double bonds and triple bonds. As well as describing hydrocarbons as saturated or unsaturated, you can also describe them as aliphatic or alicyclic. An aliphatic hydrocarbon is when the carbon atoms are joined together in a straight, unbranched or branched chain. An alicyclic hydrocarbon is where the carbon atoms are joined together in a ring structure. We're looking at functional groups, and a functional group is a part of the organic molecule which is responsible for its chemical properties. Saturated carbon chains have little reactivity, but the chemistry of a carbon compound is determined by the functional group, and it tends to be that carbon compounds with the same functional group react in a similar way. A homologous series, and a homologous series is a family of compounds, and they all have these properties. They contain the same functional group, they have similar chemical properties, and each successive member differs by 1 carbon atom and 2 hydrogen atoms, which is a CH2 group. An example of a homologous series is the alkanes, and an alkane is a saturated straight changed hydrocarbon, and Because they're saturated, this means that they only contain single bonds. Each carbon atom is bonded to 4 other atoms. They can be carbon or atoms of other elements. The shape is tetrahedral, and each bond angle is 109.5. The general formula for finding an alkane is CnH2n plus 2. I'm going to draw a table with the first 10 alkanes so you can get an idea of how this general formula works. Right, here are the first 10 alkanes, and you need to know the names of all of these for your exam. And here I'll show you how the general formula works. So when there's one carbon atom, if it's CnH2n plus 2, so there's one carbon atom, so it's 1C, then 2 times 1 is 2, plus 2 is 4, so it's H4. If you do it with ethane, it's C2, H, 2 times 2 plus 2, which is 6. So you can have a go at them all and try and figure them out. And here they are. It's methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. And they all end in ane if they're an alkane. And the ane means that they have single bonds. It's the end of the video, and we're going to go through the key definitions that are in this topic, and there's quite a few of them in this certain chapter. Right, so hydrocarbons. So hydrocarbons are organic compounds that only contain carbon and hydrogen. A saturated hydrocarbon is a hydrocarbon that only has single bonds. An unsaturated hydrocarbon is a hydrocarbon that contains carbon-to-carbon multiple bonds, like double and triple bonds. Right, an aliphatic hydrocarbon is a hydrocarbon with carbon atoms joined together in straight or branched chains. An alicyclic hydrocarbon is a hydrocarbon that has carbon atoms joined together in a ring structure. A functional group is the part of the organic molecule which is responsible for its chemical reactions. A homologous series is a series of organic compounds with the same functional group, but with each successive member differing by a CH2 group. Alkanes are the homologous series with the general formula CnH2n plus 2.